You've seen it write poetry, you've seen it accurately diagnose rare diseases, and you've probably caught those dramatic headlines about it just effortlessly passing the bar exam. Welcome to The Explainer. Today, we're tackling the ultimate questions surrounding artificial intelligence. It's a question that fundamentally challenges our understanding of technology and, honestly, our understanding of ourselves. When you type a prompt into one of these incredibly powerful systems and get a surprisingly profound, deeply nuanced answer back, what is actually happening under the hood? Is the machine genuinely thinking, or is it just running an extremely sophisticated sequence of math?
I really want to ask you this core question directly, because it sits right at the center of every single conversation we're having about our future. Does it actually think, or is everything you've seen, every beautifully written poem, every chillingly lifelike conversation, every creative spark, just a giant, breathtaking statistical trick? We are going to peel back the layers today. We're going to look past the relentless hype and the apocalyptic doom scrolling and demystify what is truly happening inside the machine. We'll explore the nuts and bolts of how it processes language, the philosophical debates about consciousness, and the real-world implications of using these tools. Because, as you'll see, the reality of AI is stranger and far more fascinating than the science fiction we're so used to.
To start unpacking this, we absolutely have to talk about the powerful illusion of the digital brain. When we interact with a system that responds in perfect natural language and seems to express genuine emotion or logic, our human brains do something entirely automatic. It's called pareidolia. This is our deep-seated, evolutionary tendency to perceive meaningful patterns where there literally are none. It's ancient software running in our modern human hardware. It's the exact same neurological glitch that makes us see a face in a piece of burnt toast or a grumpy expression on the front bumper of a car. But when we apply this same survival instinct to AI, when we see a highly human-like output and just immediately assume there must be a human-like mind sitting behind it, we are getting completely tricked by our own biology.
To really understand why we're getting tricked, let's look at the foundational elements of actual biological cognition. Neuroscientists and philosophers broadly agree that true thinking involves a few very specific, highly complex things. First up is representation, meaning the mind holds a dynamic internal model of the physical world. Then there's intentionality, where your thoughts actually have a point or a directed meaning to them. There is consciousness, or what philosophers call qualia, the actual subjective experience of feeling something, like the warmth of the sun on your skin. And crucially, there is agency, which means having goals that emerge directly from internal biological states. This is exactly why this distinction matters so much. Current AI systems process data and predict outcomes brilliantly, sure, but they lack this true biological drive. They don't have internal goals, they don't get hungry, they don't get tired, and they don't get scared. They simply execute objectives determined entirely by their training data.
Okay, let's dive into the core of how this actually works and look at the mathematical reality. The large language models powering modern AI are, at their absolute most fundamental level, next token prediction machines. Think of it kind of like the autocomplete feature you use every single day on your smartphone, but scaled up to a degree that feels genuinely magical. They are designed around one primary statistical objective, determining the most likely piece of a word to come next in a sequence. They don't read a book or a website the way you and I read to absorb meaning. Instead, they ingest hundreds of billions of words scraped from the internet. I'm talking entire libraries of Wikipedia articles, books, forum arguments, and they use that sprawling dataset purely to calculate what character or word should mathematically follow a given prompt.
Let's pull back the curtain for a second and walk step by step through the exact mechanical process of how an AI handles your prompt completely without utilizing an actual mind. Step 1. The AI breaks down your words and converts them into numbers. We call these tokens. Step 2. It maps those tokens into what data scientists call a high-dimensional vector space. Now that might sound like heavy sci-fi jargon, but you can simply think of it as a massive, impossibly complex mathematical map where concepts are grouped by similarity. And step 3, the system predicts the next token based on a mechanism called self-attention. There is no pondering here, no emotional reflection, no sudden spark of inspiration. It is pure, incredible, brute force computation happening at lightning speed.
Because the AI maps language geometrically like this, words with similar meanings naturally cluster together on that massive mathematical map. Imagine a vast universe of concepts just floating in space. King and queen live very close to each other in this coordinate system. Dog and cat are neighbors, while words like toaster or quantum are located in entirely different galaxies of meaning. The AI isn't feeling the emotional weight or the historical context of the word queen, right? It doesn't know what royalty feels like. It's simply mapping these concepts geometrically and statistically, purely based on the billions of examples of human writing it processed during its training phase.
And that brings us to a concept that brilliantly illustrates the exact breakthrough that made modern AI possible: The 2017 transformer architecture introduced something called self-attention. This mathematical mechanism allows the model to mimic deep contextual reasoning. For example, if you feed it the sentence, "The animal didn't cross the street because it was too tired," the AI uses self-attention to constantly look at every single other word in that sentence. By weighing the relationships, it mathematically figures out that the word "it" logically refers to the animal, and definitely not the street. It's almost like a statistical ghost of human understanding. And yet, this one highly specific mathematical trick is the very engine that unlocked the entire generative AI boom we're living through right now.
Now, the confusion really sets in when we look at the sheer scale of these systems. Let's compare. The human brain operates with roughly 100 trillion synaptic connections, firing and wiring together to create our lived experience. Contrast that to a frontier model like GPT-4, which is estimated to operate on around 1.8 trillion parameters. The absolute scale of biology is still vastly more intricate and chaotic. But this level of distributed, parallel computation running across billions of artificial parameters, it causes immense debate. Highly intelligent people look at the staggering complexity and naturally wonder if, through sheer scale alone, a new kind of mind is emerging from the math. But as we navigate this, we have to constantly remind ourselves, all this breathtaking complexity, all these billions of parameters, are ultimately just in service of predicting the next most likely token.
So moving on to the hard problem. Could AI ever actually be conscious?
To even begin to answer that monumental question, we have to look at what philosopher David Chalmers famously called the hard problem of consciousness. Modern science can map exactly how the brain processes visual information or controls a muscle. In philosophy, those are actually considered the easy problems. But the hard problem is the profound, completely unresolved question of why subjective experience exists in the first place. Why isn't all this incredible information processing just happening entirely in the dark, like a complex pocket calculator? Why does it actually feel like something to taste a strawberry, or see the vibrant color red, or simply exist in the present moment? As of right now, we have absolutely no scientific consensus on how matter creates this inner light.
And because we don't know the answer to that, there is a fascinating and deep philosophical split in the academic world. Thinkers like Daniel Dennett argue that consciousness is essentially an elaborate illusion created by complex information processing. From this perspective, a sufficiently complex AI might already be achieving it, or will very soon. But on the completely opposite side, philosophers like Chalmers and Thomas Nagel argue that subjective biological experience is fundamentally different from digital computation. They propose that you simply cannot get conscious experience from pure symbol manipulation, no matter how vast or advanced the system becomes. Presenting these opposing views really highlights a crucial need for epistemic humility. The sheer fact that we cannot definitively answer this means we must be incredibly careful as we push this technology forward.
Let's shift gears to grounded reality, separating the real risks from the sci-fi myths.
So the crucial point in all of this is carefully matching the tool to the task. AI is genuinely extraordinary at executing pattern recognition at a massive scale, doing things like modeling complex protein folding for medicine or analyzing thousands of medical images in seconds. It's absolutely amazing at language translation and summarizing huge documents. But it is equally important to understand where it fails. It fails confidently at causal reasoning and navigating completely novel situations. Why? Well, because it completely lacks a grounded reality. It has zero common sense because it has never touched a hot stove. It's never felt the weight of gravity. It has never lived a day in the physical world. It exists entirely and exclusively in a universe made of language.
Understanding that limitation helps us thoroughly debunk the sci-fi myths right off the bat. The persistent ideas that AI will spontaneously become conscious, develop secret goals of self-preservation, or decide to pass judgment and destroy humanity are incredibly common tropes. But we can safely put those Hollywood Terminator anxieties to rest for now. Current systems simply process text based on mathematical weights. They absolutely do not have the agentic architecture, the biological drives, or the internal persistence to harbor secret malicious plots against us. When the machine generates a spooky or judgmental response, it's merely mirroring human language back at you. It is not actually evaluating your worth. However, discarding the science fiction absolutely does not mean there aren't massive immediate dangers. The real risks we face right now demand our full attention. We are looking at the generation of highly convincing misinformation at an unprecedented global scale, which threatens democratic processes. We are facing severe automation displacement that's going to aggressively disrupt careers and human livelihoods. There's an extreme concentration of corporate power currently underway where a very small handful of tech companies control black box tools that will affect absolutely all of us. And perhaps most dangerously on a daily basis, there's the risk of misplaced trust
deploying these language models in high-stakes domains like medicine, criminal justice, or law without truly understanding their invisible failure modes or the severe human costs of their errors.
This is exactly why our collective approach to this astonishing new technology matters so deeply. True power comes from rigorous understanding, not from indulging in mythology. It's so incredibly easy to project our deepest fears or our wildest fantasies onto these mesmerizing machines. But learning their actual underlying mechanics, understanding that they're ultimately statistical prediction engines and not magical, omniscient minds, that genuinely empowers us. It empowers us to push back. It empowers us to demand transparency from developers, to mandate safe and ethical deployment across industries, and to steer this profound technology toward being a stabilizing accelerator for human flourishing rather than just a chaotic disruptor.
Which leaves us with this final, kind of staggering thought to carry forward. We are quite potentially attempting to build digital minds without fully understanding what biological minds actually are. The choices we make right now in this exact moment of history carry immense philosophical weight and deeply practical consequences for the future of our society. We have to be willing to sit with the real, uncomfortable uncertainty of this technology, strip away the magic, and relentlessly ask the hard questions. So, as we step collectively into this entirely new era, are you ready? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you in the next one.